What's up, YouTube? This is my C++ Minecraft clone. We'll do a summary of what happened in the previous stream so you guys have context, and I'll even give a summary of what happened off stream because I do a bit of work off stream as well. And then we'll do a vote, a poll on what we're going to focus on today. And at the end of the stream, we'll do a summary of what happened during this stream, which should be in about 3 hours from now. So I'll give you guys some context. This is for new people that just started watching the series, because that's very important. Most people that watch are new people. Yeah, I'll do a summary. So here is what we did as a quick rundown. Like, we have caves. And also we added the particles. Look at this. Look at this, man. Like, this is like awesome, man. Look at this. This is my favorite feature. Yeah, we added particles, and look at how the particles work for different blocks. Now it's using the stone texture. And this is using the dirt texture. This is using the lock. And this is using the leaves, but I'm not changing the color, sadly. How are you? Fine. And so in one of the previous streams, chat voted we do the caves. We did the caves. In the next stream, chat voted to do particles, and we did particles. And chat today will also vote what we're going to focus on in these 3 hours. And I'll do my best to try and implement it. Like, I'll do my best, guys. You should scale down the particles. Yeah, we'll scale them down, but we'll see what... we'll focus on what the priority is. For the scaling down, we'll think about it. And this is just a texture. This is using the Faithful texture. And I also, off stream, I did some changes. I fixed the UI, hopefully, because every time we started the game, sometimes the UI was bugged. I think I fixed that. And there was another bug when you restart the game. It wasn't starting. You had to restart it a couple of times until it actually starts. But now it should start the first try. So that was very cool. I managed to do it, but that was off stream. And also somebody mentioned to you, because look at this, man, the main CPP file. Look at it. I cleaned it up. This was off stream. Somebody like said you should watch the Cherno application series, how to structure the application, and I did that. I've done that before, but I've actually implemented here in this clone. So look at the main file, how clean it is. But it's not that organized because we just moved everything under the rug. I just moved it to this like game layer file here. I just moved it here. It's still a mess, but at least it's inside of game layer and not in main CPP. And the other cool thing is we have this application class, which has the main method inside it, the main while loop inside of it. And it has this function where you can close the game. Yeah, this one, close, where you can close it. And it just stops the while through loop. And it's a singleton, the application. I just need access to this instance, and which is static. Everywhere I have access to it, and I can call close. Just what I did here in the game layer, where I hit the escape key here. I just call the application, I get its instance, and I hit the close function. So I'm very glad I did this cleaning up. So what's up, guys? Yo, okay, what's up? And also, like, we have the player. This is also from a recent stream. Like, we have the player. We even have like the bunny hop. Like, this is from the source engine player movement. This is from the source engine. And that's kind of the summary. We have Crank Obsidian. Look at particles still work for this. Look at it. Particles still work for it. What's the summary? We're just going through it right now. Why did you change from textures? What do you mean? And so this is the start of the stream, and viewers that manage to join the stream early decide what we're going to focus on. And so usually I just open the notepad, and here we go over a few ideas, and you guys will pick what we focus on. So I have a couple ideas, which is from the previous streams that didn't win. So one of it is sounds. That would be very cool. Another is weather. That would be cool. A new biome. That would be cool. Custom culling. Optimization. More FPS. That's another thing we can do. You guys can do suggestions as well, what we're going to focus on today. 3D noise, that's something else we can do. Rivers, maybe, question mark. Yeah, we run wild here. Crafting. Oh, Dimitri, yeah, from previous stream, I remember you. You really wanted crafting, and now you managed to join early on. Ravines, is that how we spell it? Ors? Ors, what else can we do? Yeah, ors, I wrote it down. Mobs. Which mob? Question mark. The end. Why not? Why not? Why not? The nether. What else can we do? Also villages. Other structures. It should be specific structures. Visual vibrance. I don't know what that is. The dragon, but that's part of the end of the end update. What else are we missing? Shaders. We attempted it and we failed. When we fail a new feature, we'll do it some other time in the future. I'm not going to include features we've attempted and failed. Single player inventory. 3D Steve. We also can do right hand item hold. We can do item drops. We could continue particles because they're not finished. We could do a multiplayer, bro. Are you crazy? Multiplayer. Add myself. Potions. No, like potions. Furnace. I don't think furnace is that would be that cool. All the mobs like chicken, cow. We added here the weather in this list. We could do day and night. We're ready to work more on particles. 500 items. I think 20 is good enough, guys. What do you think? 20 is good enough. So now, tools and weapons. Tools and weapons. TNT. Guys, we need to put a limit at some point. And so now, I think this should be enough, kinda. And this should be enough. And so now, guys, start typing the numbers. What do you want to see implemented? And we'll do a poll. I need to pick 4 items. When I create the poll. And don't spam because you'll get obliterated. Start a poll. Here, what to do. So 22, 5, 7. I need them to repeat. But don't spam them. 9, 5. Okay, I see 5 a couple of times. I see 5 or 12, 22. 22, okay, I saw 22 2 times from different people. It needs to be from different people. 22. Yeah, I added 22. Okay, 7. We got 7 from 2 people. We got 7 from 2 people. Yeah, we added 7. And one last one. One last one, guys. One last option. One last option. 10, 1, 15. I needed to repeat. I needed to repeat. Yeah, we already have 7. We already have 7. 10? Okay, I saw 10 a lot of times. I saw 10 a lot of times. Okay, let's start this poll. What? Yeah, let's start this poll. Okay, because 4 is the limit. 4 is the limit. And let's see the results. Let's see the results. I know who the instant vote on 7 is. I know who that for sure was Dimitri, the instant vote on 7. We need a clear winner. If an option doesn't win, we'll do new numbers probably. Or another poll on the same ones. Yeah, I think 10 is winning. What's 10? Mobs? Oh, no, not mob. Bro, no. That would be very difficult, man. That would be very difficult. But particles was also the same reaction, so we don't know what will happen. Okay, this vote is for what we're going to focus on during these 3 hours. So if you like pick number 22, that will be TNT. If you pick 10, that would be mobs. If you pick 7, that will be crafting. And 5 will be 3D noise. And nobody wants 3D noise. So for now, it looks like we're doing TNT. But it's very split, man. It was very split. Yeah, okay. I think we are going to end it. Can you add all of them in different streams? We'll do in a different stream another poll, and hopefully it wins. Hopefully it wins. With TNT, we are all going to see performance. What do you mean performance? Yeah, that's 27. That's the maximum. There's nobody else to vote. Yeah, so we're doing TNT. Oh no. Oh no, man. We're doing TNT. So let's update the title to be TNT. TNT. I updated the title. And here in Minecraft, we need to start from some kind of a reference. That's what win. No matter what your guys' opinion on TNT is, that's what won. And so it's like we have a democracy here. That's what chat did. But it was kind of like even. It was even. 3 options kind of almost won. And here I'll update the stream. I'll update the stream thumbnail to be TNTs. So that everybody clicking will know we're doing TNTs. Yeah, okay. I updated the title. So this is what we're going to implement. Hear me out is going to sound like... And so what's a TNT? Everybody knows what's a TNT. It explodes like this with a flint and steel. And it explodes. Bam. This is what we're implementing. And obviously when we have multiple TNT, it interacts with each other. And when these blow ups, these ones, they blow up faster. Because, yeah. What do you mean good luck making the... Oh, the TNT? Wait, does it have particles? I didn't look at it. Oh yeah, here it has particles. Oh, but this is the generic texture. Oh, this part... Oh, yeah, when it explodes, it has the particles. Oh man, what... Oh, this will be... So first we need to add it here, actually. we need to add it as an item, like a regular item like this. We need to add it like a regular item, just so we can interact with it. People choose the hardest option. I should have a little bit of authority on this, since in the main channel I did like 10 million TNT, but that's a bit different. Here I did 10 million TNT. That's my experience 7 months ago. I did 10 million TNT, but that was using shaders, compute shaders. It was a bit different. This was the in C++. So I do have a little bit of experience trying to do TNTs, but this was heavily optimized. Heavily optimized. Yeah, this 1 million TNT. But we're not going to do something like that. We're not trying to do optimization. We just want TNT. One TNT that should be exactly like in Minecraft. And so let's first create the TNT block. Let's first create the TNT block. Thank you, SoBite Lee. Thank you, Mr. Lee. Yeah, so this block should be the TNT texture. Let's do that. And I've already done some simplifications. Let's first do a save here. Big-Sim GUI crash on exit. Okay, so we need a new block, and I just need to create a JSON file. Try ray tracing for TNT explosion. I think rays aren't that laggy. Yeah, we'll probably do rays because I think that's what Minecraft did. Did you add the colors in the particles? No, I didn't. So let's create it here in resources, blocks. Let's copy the one of the blocks, the sun, for example. Let's just copy paste it and rename it to the TNT here. And this should be TNT. This should be TNT. And do we have a model for it? Yeah, we have TNT JSON. TNT JSON, and we should have it. We need one more place to do changes. We need, I think, in the world. Here we need to link the ID with the tag. The ID with the tag. I also started making a Minecraft clone after inspiring by you, but I'm trying to make it in Rust Raylib. Will it work? Well, you have to try and see what happens. That's the fun part. Like here with the TNT, I don't know what will happen. Even with the particles, I didn't know what will happen. And I was pleasantly surprised. So you need to do it no matter what you feel at the start. Like, ignore what you're feeling in the moment, because your actions change the way you feel. It's not the other way around. Like, don't wait for a feeling, just do the action. And the feeling will come from the action. And here we have the TNT. And it has particles as well. Oh, let's update the thumbnail. Let's update the thumbnail. But it has here the particle. Yeah, let's do it like this. Update the thumbnail. Like this. Screenshot. And we will update it because the other one was using the Minecraft. Save. Okay, we're done. And let me bring back chat and we continue. Yeah. Okay, so we have the TNT block, and when we look inside, it's culling. It's culling properly as well. So that's nice. So that's nice. And it has automatically the particles. Where did you come with the idea of making the Minecraft? Because I wanted to learn how to program. Stream again, my sleep schedule is fucked. Yeah, so what's next? What should we focus on next? We have the model, we have the block here. We needed to make it explode. We need to make it explode. Oh, flint and steel. We don't need flint and steel. We'll just make it so if you right click it, it explodes. We will not do flint and steel because we don't have items and tools yet. We cannot. We cannot generate a model for it because it generates it through the pixel art, and we still don't have that in this particular clone. So let's open the game. Let's open the game here. So what we're going to do now? Should it be this glowing effect or directly the explosion? To directly explode it. I think directly the explosion would be better. Probably. Directly the explosion. Is there... No, there isn't anything else. Make TNT explode animation. I think you can light it with redstone torch. Yeah, it doesn't matter. We'll do it with a right click for now, and we'll improve it later on because we have a limit of 3 hours. Yeah, I think it would be best to make it explode. Summary is very quick. The summary is basically that chat did the vote on what we're going to do, and chat decided we're going to add the TNT. And we added it as just a block. It's like all the other static blocks. It's nothing fancy. Here, it's just like all the other blocks. It's nothing fancy yet. But we'll make it explode. I think this would be the best thing to focus on, because if we run out of time, it's best at the end to have just the explosion rather than just the animation. You get me? It's a priority. So let's do just the explosion, and we'll at the start ignore the particles. We will ignore the particles, and we'll ignore the particles like this, the smoke and the explosion particles. We'll just do the explosion itself. We'll just do the explosion itself. And so how does the explosion work? Yeah, when I did the TNTs, when I had the 10 million, like the 10 million TNT video, and I said the way I did it was a simplified, optimized way, and people in chat were like, no bro, Minecraft does it differently. Minecraft casts rays. Minecraft casts rays when the explosion happens. And so what does that mean? We need to open up Excalibur because I solve problems with visually. I need drawings here. I need drawings. Like here with the particles, we need drawings. Let me copy the TNT here. Let me copy the TNT like this. Let's copy it. We can do it smaller. And let's go in Excalibur. Here is the TNT. And let's say this is the blocks around it. This is the blocks around it. Like this. And so what happens? The way I did it in my video 7 months ago, the way I did it is I just, when the TNT exploded, I just go over the blocks. You are gone, these are gone, these are gone, these are gone, and something like that. I simplified it a lot. But what people in YouTube chat said is actually Minecraft has rays going from the TNT. So let's do it in red color. So when this explodes, it fires up rays. So which is just arrows in a certain direction, like this. It fires up rays in random directions. And when they interact with the block like this one, this gets destroyed. This gets destroyed. This gets destroyed. The result is similar. We also here get blocks destroyed around the TNT, but the creator is more realistic. Because if we did it simplified, like just destroy a few blocks around it, it will be very artificial. It will be very artificial. it will be something like this. It will be very clean. It will be very clean. But if it was arrays, some array would have destroyed this one. Another array would have destroyed this one, this one. It would be more random, like an explosion. And so that's what we are going to do. But we'll do it at the start very simple. When we right click it, I want it to remove, like if it has blocks around it, I just want to remove the blocks around it, just to test that I can remove blocks. Here, when we destroy this, all of this to get destroyed. Just this, no arrays, no complications. We'll keep it simple, just so we can see if we manage to remove blocks when interacting with the TNT. Once we confirm we can remove blocks, then we can do the arrays, which would make the crater more realistic. And after that, I'm planning to, when it interacts with another TNT, to make it explode as well. And then this will explode this will explode this, which will destroy more terrain. Yeah. You get the idea, right? Right, chat? What's with the textures? What do you mean, what's the texture? How's it working? That's crazy. What do you mean, United States? What do you mean? What do you mean? But let's focus on the TNTs. The focus of this stream is adding TNTs. That's the focus on this stream. Textures are auto-randomized. I don't get what you mean. But let's focus on the TNT. Let's make it so when we interact with this TNT to destroy the terrain around it. It will be very simple, like this, to destroy the terrain around it. That's my goal. Then we'll move to making the crater more fancy. We'll make it more fancy. And then we'll make it explode other TNTs as well. Thing he means, for example, is the grass facing a different direction every block? No, the grass is the same everywhere. I'm keeping it simple. Bro, missed my chat. Where is your chat? You missed my chat? I survived the night on my web port version on my TV. While I died in the nightmare future on beta. Yeah, I got it. Yeah, okay, let's do it. So this is the goal. When this gets destroyed, I wanted to destroy the terrain around it. That's the goal. Very simple one. Very simple goal. Let's do it. So we added the TNT. That was very simple. We need now to create a class for it, because we'll have an interaction with it. Should make so grass needs block below it so it doesn't float. That's not a problem. It's not a priority. And here, let's copy this and we'll make a class just for the TNT so we can interact with it. This is the TNT. We don't need custom mesh generation. The textures are 64 by 64. That's why they are higher quality. And now we need to connect the block ID with this class so that the game knows it should use it on certain function calls, on certain callbacks. So where does this happen? It happens in the block factory here. And here, if the ID is TNT, here we create the TNT class. That's it. And let's make it on right click let's have the on right click callback. The reason we never go. Where is the callback? I had a function that was called when you right click. Yeah, on right click. Here we'll add it, and we need to add some implementation for it. Let's make it so the world, we change the position details, set block type to air. Let's just set the current position to air. Let's just set it to air. Now we should be able to right click a TNT. Yeah, that's a new chat display. And so let's right click it. Now what I'm expecting is when I right click this TNT, it should disappear. Okay, let's right click it without without holding a TNT. Okay, it should disappear. It didn't. Oh, did it? It didn't. No, it didn't. Do I have the other interactions working? Yeah, I have the other interactions working. So this on right click, we set the block type to air. So this is looking for the sub chunk, and it sets the block type. So what's up then? What's up? Why? Is it actually finding this TNT class? Is it actually using this? It's a structure. It's not exactly a class. Is it actually using it? Here, let's do a breakpoint to see if we get this called. If we get it called. Ah, yeah, it's getting called. Yeah, it's perfect. Okay, and so, okay. And so let's add a breakpoint here to see if this is getting called here, and let's run it. What are you actually doing today, TNT? We're adding TNT. And so now when we right click it, no, the breakpoint doesn't activate. So this function just doesn't get called. It just doesn't get called. And so where does this code, where do I expect this to be called? Let's search it, the function name on right click here. And this is for the hovered block. This is for the hovered block. Oh, if it has a block state or not. That's the idea. If it has a... Oh, it doesn't have a block state. That's the problem. Yeah. So what block state does it have? A block state is basically like... what's a good example for a block state? Here, the trapdoor. This has block state because you can interact with it. And if you go with F3, you can see here in all of this mess. Where should it be? Oh, on the bottom right. Yeah, here on the bottom right, we can see here. Here we can see it's a trapdoor. It's facing the south, and it's the bottom half, and it's not opened, and it's not waterlocked. So this is block state. And this TNT has block state if it's unstable or not. And what's the difference? Oh, now it's an entity. We can, let's test what this unstable block state is by giving ourselves a debug stick, which allows us to interact with this block state. Debug stick, like this. And let's change it. Now unstable is set to true. Let's see what that is. Let's get back the flint and steel. So this should be an unstable TNT. And nothing changed. But we'll give it the state. We'll give it unstable. So it's true or false. It's true or false. So let's make a new state. Let's make a new one, which is in properties here, and it should be a boolean here, boolean. Let's make it, and it's called unstable. The property is unstable. What else? Here, property unstable, like this. And what next? Oh, we need to give it to the TNT block. We need to give a default value to it. So where is the TNT? Yo, what's up? This is the TNT, and here we need to give it state. But let me take as an example this. We need to give it state like this. We need to give it state, and here unstable by default is false by default. Now we should be able to interact with it. Now we should be able to interact with it. Oh yeah, we need to make it, the parser doesn't recognize what this means. We need to link it with the unstable property, like the actual class, which should happen in here, I think. Load structure file, load block file. And here we need to link it, the unstable, with this unstable. Now it should have block state, the TNT, so we can interact with it. Now we should interact with the TNT. Yes, we managed to interact with it. It disappears. It disappears, but we need to remove the block state as well. We need to remove the block state. But it manages to remove blocks. It managed to remove blocks. So let's go back to the TNT, which should be here on right click, and here world. We can check it here actually. Here, when we set this, and here we need to remove the block state. Else we need to remove the block state. So we find this index and we erase it. Yeah. This should remove the block state. Okay, let's test it. So now when we right click TNT, I expect it to disappear. Okay, it manages to disappear. Perfect. Now when we right click TNT, let's make it also make these blocks disappear around it. Let's make these blocks disappear as well. That will be the next step. And after that, we'll make the crater be more fancy. And after that, we'll make it interact with the other TNTs. So here we have the position of the TNT. We need to go around it. Why would you need the source code? If I'm going to give something, it will be the executable, not the source code. But I cannot give the executable because I need to give the meshes and the textures, which I don't have rights to. Here we need to go around the block. How are we going to do that? Let me see. Let's do a test. Yo, what's up, member? Sup? Hello, I want free Minecraft. You should make function for that. For what? Bro thinks my mod is an AI. My mod is not an AI. What was I going to do? I forgot. Chat, what were you going to do? I forgot. Yeah, I was going to look at the directions which direction is the positive or the negative actually. Negative Z, negative X. So we need to go to the west and north and up. We need to go there. So we need to go west, north and up. And from there we'll do a for loop to go around the TNT and set all the block types to air. So let's do a position starting point. It will be the current position details. We need to get the up, and from there we need to go west, and from there we need to go north like this. We have the starting point, and now let's do a for loop. To go around the TNT and remove all of the blocks. X less than, so it should be like 3 by 3, right? Should be 3 by 3. but we'll go 2 times. Something like this. Yeah, this will make it so we go around the TNT. TNT has to give you... Bro. Here, this will be the Y. This will be the Y. This will be the Z. This will be the Z. And so what now? So what now? Let's do a current point. Equal current point, which let's copy the starting point. Let's copy the starting point here. The current point will just go towards the east, and here we'll just go towards down, I think. Wait a minute. Here let's go down, actually. Go down, because here I want to go up. We go up, and here we go to the south. This should iterate over the TNT. And this is just to keep it simple. We'll make it better later on. But let me think about it. So, and here we need to change the current point, set block type to be air. We need to set the block type to be air, like that. And what else do we need to do? We need to restart the positions. When this for loop is over, we need to go back. So the current point, we need to go back to where we started here. So a starting point for each one of these. So here, position details, starting point to be a copy of the current point, I think. And here we go back. Here we go back to the starting point, I think. Right? Let me think about it. I'm trying to visualize this in my head, and that's why it's like this right now. Trying to visualize it. Let's do it visually in a graph here. And so what's happening? Let's place them down. Let's place them down. This is just blocks in 2D. This is just blocks in 2D. And here is the TNT. And so we went from the TNT position, from here, from this TNT position, we went down, and we went to the west and north, which should be here, And basically what I'm doing is I'm calling this delete yourself. But then we need to go back. We need to go back here and go up. So we can do this here, here, here. And then we need to go back and we need to remove this and this and this. And so when does this going back start? We did something like this in the structures. When we implemented structures, we did something like this. So we can just copy it over. Which should be here. The structure block on the right click question mark. Yeah, probably here. Yeah, here. Yeah, this thing. We need to copy this thing. Because we already did it once. And here we go to the TNT. And we'll use it as a reference. Here. And so, yeah, here we do the same thing. Like this. So this is the up neighbor, and do we go down then? Up neighbor, no, we continue to go up. I need to rename it. No. Let's, yeah, it's fine. It's fine. And here we do this size. This should be 2 by 2 by 2. 2 by 2 by 2. And what's this index? That's something else. We don't need to worry about that. And here, what do we need to do? Here we need to set the block type. We need to set block type to air. We need to set it to air like this. This should be enough. And which directions do we go towards? We need to go towards east, towards the south, and we go down. Yeah, let's leave it like that. And this will just comment it out. And now let's test it out. We're adding TNT, which I repeated many times, but probably just new viewers come. It's probably just new viewers. Okay, what are my expectations? I expect when we right click this TNT to get removed and these blocks around it to get removed as well. That's what I expect when I right click it. So let's see what happens. Yo! We need to change the size to be 3 by 3, I think. We need to change it to be 3 by 3. Oh, wait a minute. Where is it starting from? It's starting from here. Oh, we need to update the subchunk mesh as well. We need to update the mesh. Let's make the size 3. Let's make the size 3. This is so we can confirm we can remove blocks. And chain explosions will be a bit later. And let's see what happens. Okay, now it's working. And here, these sides are missing because this mesh has not updated. So when I remove this grass, it updates this mesh. And when I remove here, it updates this mesh. These meshes are just not updating. They're just not updating. But we can easily fix that. Here, when we set the block type, we need to set the position here, south neighbor. We need to set position as dirty, which will ask for a redraw. It will ask for a redraw. Put size in variable. We don't need to because we'll be changing this code. We'll be changing the code. Okay, now it's fine. Now we have a little bit of an explosion. And maybe to do the chain reaction now, or maybe to fix the crater, to use race. Look at it how... It's for fast cleanup. Look at it, it's for fast cleanup. Yo. Yeah, this is like a cool axe, a cool pickaxe. Can it break water? Let's see. I think it can break water, yeah. It should be able to break water. Yeah, it broke water. It broke the water. Okay, obviously we need to improve it, but we have plenty of time. The limit is 3 hours and we are still not done with the first hour. So we have plenty of time to improve this. We have plenty of times. Let's go to the Minecraft and see what the crater is in Minecraft. Let's remove this and let's see what the crater is here. Yeah, and this crater is always different. Look at how it's always different. And like chat says, this is because it's casting rays. So we will cast rays from the explosion itself. We'll cast rays, and when it hits a block, it will destroy it. Right? And this will drastically improve the crater, and that will drastically improve it. Once we do this, once we have this crater, once we have this improved crater, we'll make TNTs interact with each other. So when this one explodes, to make the other one explode as well. To make the other one explode as well. And then, once we have this, we'll make the TNT be an entity. So like here, you can... Like from here, look at now it's a block. Yo, what's up? I'm glad you're back. I'm glad you're back. Do incremental ray casting on blocks. Minecraft doesn't do this, and that's why it's so laggy. There are different block healths. Example. First block has 1 health, which explodes easily or breaks faster. Second block has 10 health, which explodes harder or breaks slowly. We'll see about that. We'll experiment. But look at this. This is the last thing we'll do to make it an entity, so it can interact with the world. So it can interact with the world. But first, let's make the crater be more realistic. Because right now, our crater is very simple. It's very simple. It just goes around the TNT and removes everything. It's very simple. That's our next goal. That's our next goal. Or, yeah, we'll do an attempt. We'll do an attempt to have a better crater. If we cannot make it better, we'll keep it something like this, simple, and just move on with the interactions and making it an entity, so it interacts with the world, because that would be a priority. But we'll do an attempt to make the crater prettier. We'll do an attempt. If it doesn't work out, it's fine. We can afford to risk it because we have plenty of time. We have plenty of time. So it's fine. So it's fine. But let's do a commit at not here. At simple TNT like this. Oh, we need to push it. Push. Okay. Hi from Twitch. What's up? What's up? Hi, how are you doing today? I'm fine. Let's improve the TNT crater. Let's improve it. And the code should be here. We should have the code here. This is how I think it is. No, don't worry about it. Don't worry about it, chat. If I look at chat suggestions, it will be like looking at an AI. It just it breaks the goal I have to learn. If I just copy paste what chat says, it's not learning. It's like using custom AI. It's like using the chat AI. So I want to avoid looking at what chat suggests. Sometimes they're very good suggestions that are worth it, like these ones. Here, when gaming said that velocity may not be initialized, that was golden. Or here, when another viewer asked if the caves are removing the blocks constantly, this caused a big memory problem, like it tanked the FPS. So some chatters are like golden, man, with their suggestions. Some have golden suggestions. Dude. Why do you get east neighbor from up neighbor? Don't worry about it. We'll be changing the code. We told you to use templates. So what now? What now? We need to do race. We need race. We need array. And so this code that we wrote was just a draft. We'll comment it out. We need to think of something else. We need some kind of array. Array is just a direction. It's just some kind of a direction. It's some kind of a direction. Let's have a single array. Let's have a single array, and we'll go in its direction, and when we find a block in the direction of the array, we'll remove it, a single array. And then we'll do like 50 arrays in random directions and see what happens. I want to see what happens. And then we'll have to do some changes for sure. But I think this will be a fun approach. Here, let's remove this. Let's remove this. So we are creating array. We need... let's make the array direction be just downward. Let's make the direction be down. So the y-axis -1. We don't need a random direction yet. And what now? Well, we can just copy paste the raycast from the block placement and removal. Raylib is amazing. Because for removing and adding blocks, I'm also doing a raycast. Here, from where the camera is looking, I shoot up a ray, which is just like a vector, and I can remove a certain block. So we'll use the same code for the TNT. We'll use the same code for the TNT. And where is the logic? Let's go to the game layer. And here, let's search up raycast. Here, this is the code. This is the code. This is the code. We probably need to abstract it a bit, but we'll think about it when we add more arrays. Yo, Dimitri, you followed. I made an account in Twitch too. Bro, Twitch got a lot of new accounts from me. From people transitioning to there. I don't know why people prefer Twitch. Here we need to copy this code over. We need to copy it over. We need to copy it over. But up to where? Up to here, maybe? Yeah, up to here. Up to here, and then what? We just copy it, right? Here, we copy it. In when we... Yeah, here in the TNT, right click, here. And here we have the array. We'll put this in a separate function so it's abstracted, because we'll use it multiple times. We'll be using it multiple times. So this is my array direction. Just curious, why do you add random features instead of importing game mechanics? What do you mean? Why are you calling the TNT a random feature? Bro, what do you mean random feature? So this is the starting point. We need... We'll use the TNT position details. We'll use the block origin, but we need to add to it from the center. I need it to be from the center of the block. It's from the center of the block. Your raycasting is seriously bad. That's good if it's bad. That means there is a lot more to learn, and I want to learn more. So thank you, and thank you for the suggestion. Like, people in the main video also gave me suggestion for the raycast, but for now it's fine. When it causes problems, that's when I look up optimizations and improvements. But for now it does the job. For now it does the job. Let's start from the center of the TNT. So it's from the block origin plus 0.5 on all axes, I think. On all of the axes. And this is vector 3. So that's the starting point, and the direction is down. The direction is down. The direction is down. And we'll also like destroy the TNT itself before we do anything else. We'll destroy the TNT. And so now we have a raycast. We have a raycast. What you making? We're adding TNT. And so we're going downward and we're moving in the direction of down from the TNT origin. We move with a little step, like 0.01 increment. And what else? What else? Here we'll do a boolean if you're still searching. True. Sure. And what now? And here it is checking if it's colliding. If it's colliding. Sure. So here we are colliding with a certain block. We are colliding with a block. And we want with this block to, what do we want? We want to remove it. We want to remove it. So we do current block. How many hours did it take to make the Minecraft clone C++ and that stream? Like the C++ clone took like 5 weeks, more than 5 weeks, something like that. But this C++ clone. And so what now? Yeah, we need to set the type to air. That's it. And we don't need all of this for now. We don't need all of this. So we should have a raycast in the down direction. We should have a raycast in the down direction. Sure. Like this. Let's add the TNT. And now what do I expect? When I right click this TNT, I expect it to be removed and it to remove the block below it. That's what I expect. That's what I expect. So let's right click it. Yo, it happened. Okay, the raycast works. This was our first raycast. It works. That's our first raycast. So maybe, look at this. Look at this. Look at this. So from here, if we destroy it, what do I expect to destroy this block as well? Because the raycast should go from here down with the length of 10. And let's see what happens. We right click it. I want to see what happens from here. We right click it. Let's go a bit down. Here we right click. Yo, it happened. It did it. It did it. Yo. Bro. The raycast worked. Look at how it continues to destroy. Oh, we need to set we need to update the chunk mesh. We need to update the chunk mesh. Here. We need to update the chunk mesh. Right? Yeah. We need to update the chunk mesh. I think I need to deal with somebody in chat. You have to get muted. For one day should be enough. One day should be enough. Chat, did I do? Yeah, I think I did the right thing. Can you unmute me? Can you mute me? What? Okay. Sure. Okay. So we have raycasting. Let's also set the position to be. Let's update the mesh as well. Let's update the mesh as well. Here, current block. We need to set the position to dirty. Okay. And now the mesh should get updated. But we now have a single raycast. So this should be very exciting when we add 50 raycasts. Yeah. Now it manages to destroy the block below it. Even if it's from here, it destroys the block below it. Because that's a raycast. It manages to destroy the block below it. So now We just need to add like 50 raycasts. Like 50 raycasts in all kinds of different directions. Each new block or step have higher chance of raycast to end. So what now? Now we need to do many raycasts. Like this was a single raycast and the direction was fixed. Let's make the direction random and let's abstract this in a separate function. Let's abstract it into a function. We'll just use a lambda. TNT ray explosion equals like this, like this, like this. And let's just move all of this code. Let's just move all of this code like this. And so what now? Here, let me think about it. Yeah, starting point is always the same. Starting point is always the same. Let's get reference to it. Starting point. Let's get reference to it. It's always the same, but the direction is different. The direction is different. So let's pick a random direction. We did something like that with the particles. When we had to pick a random velocity here, like this. Like this. Yeah, sure. And here we'll pick a random direction like this. So this is the raycast direction and this is the raycast direction like this. Sure. Now the direction should be random and let's do like 50 explode, like 50 raycasts, like 50 rays. Let's do them. So here let's do like 4 int I equals 0 I less than 50 I plus plus, and let's do here TNT ray explosion. This will pick a random direction every time. And let's see what happens. Let's see what happens. I'm curious to see what happens. Now we should have 50 rays in random directions when we right click the TNT. So let's place it. Now what do I expect? I expect when we right click this TNT, I expect it to start destroying blocks all around it in all of the directions. So let's see what happens. Let's right click it. Yo. Oh, some of the directions are digging down in the same spot. What? Let's limit the length. Let's limit the length to be not 10 because the raycast, look at it, it reaches up to 10. Let's make it be shorter, like up to 5 blocks. Or like, let's see in the original game here. So it exploded. How many blocks here? How's the height? So it's 1, 2, 3, 4. Yeah, around 5 radius. Around 5. So here, let's do it if the length is less than 5. So now the crater should not reach that much. Try it in a cave. Better than cave generation. You're my favorite programmer. Thank you. I appreciate that. I'll do my best. Yeah, so it exploded. And so here, look at how it was like from here. It was like from here, an array exploded here. Array exploded here. 50% chance of array breaking the block. Oh, so there's a chance of breaking it. Oh, this crater was a good one. Oh, let's do it in cave. Yeah, like you guys suggested. Oh, we can do something else. Oh, let's do this. Let's do this. Look at it. Let's destroy here a block. And let's add here a TNT. Did we add the TNT? Okay, it exploded. It just directly exploded. I just right-clicked the TNT. So that's the crater. This is what it creates. This is what it creates. So it's more to the up and to the down. Not that much to the sides. Oh, wait. No. Yeah, where the random direction is from 0 to 360. It's from 0 to 360. Now we can do more race. We can do more race. We can do more race. Let's do 100 race. Let's do 100. Here, let's do 100. 100 race. It's not RNG, it's based on blast resistance. Let's see how it looks like now. And let's right click it. Yo, 100 race. I don't know, guys. I don't know. It looks kind of fine. Yeah, it. Maybe the race to have a priority up and down, maybe, or like the distribution. The random values are too random. We could distribute them better. Like the race casted are too. They should be not that random, so we can get a cooler shape. Like, look at this shape. That's very weird shape. Let me think about it. Yeah, because the rays take a random direction from here. We take a random yaw and random pitch, which is just the up and down and left and right, from 0 to 360. You could assign blast resistance, that would be a good fix. I don't know about that. Not sure about that. But let's look up blast resistance. Minecraft. Let's look at blast resistance. And here let's search blast resistance. Here. Oh, what's this? So is it like health bar, the blast resistance? Is it like health bar? The blast resistance. So if a ray hits it, it just damages the resistance? Question mark. And should a ray continue onward? Oh, we'll have the ray have points to it. The ray to have points, like 1000 points. And then when it reaches this block with a 6, the ray gets lowered from 1000 to like 994. But if it reaches obsidian, the ray with 1000 doesn't get through, and the obsidian survives. Depends on how much it is. There's a chance of it getting damaged. Do you plan make TNT explode? This is what we have as options and kind of the summary. So we're implementing the TNT. And what we got so far is we have the TNT block and we can right click it. We can right click it. We can right click it and it casts arrays from it, which is just vectors towards particular directions. And when they reach a block, they destroy it. And the crater, this is the crater we get from the explosion, which is not that cool. I want it to be wider. Like here, instead of digging down so much in the same spot, to spread out more. And to get this, chat is suggesting to have block resistance, but here, even if we have block resistance, like if the blocks are all the same, the result will be like this as well. Something else we could do is here when we create the direction, the random direction of the raycast. I just pick random values from 0 to 360. And this function, I don't know how it picks a random value. Maybe it's completely random. But if you have taken like probability and statistics, you would know that there are different types of random values. So like there are different distributions, like normal distributions, etc. So we could probably change how we get the random value to be more equally spaced out. That's one option we can do, to be more equally spaced out. So that instead of, this is my concern. This is my concern. Where is it? Where is the Excalibur? Here. This is my concern, what's happening. Here, instead of having this, I think we'll have more something like this. Like the random values are not that random. Like we get something like this. And some blocks get left out. This is my concern. That the random values are not what I expect. But we don't need to actually make them random. Bro, we can just like every ray, like to start from one direction and this direction to just increase it by like 15 degrees every time. Like to just like a clockwork. Bro, like we can just do this and it will be good enough. It will be good enough. Instead of it being completely random, right? Don't read my name, isn't important. Yeah, I have a suspicion about your name, but don't worry about it. Twitch is a second chance for everybody. Twitch is a second chance. If you mess up Twitch, then it's like a ban. Like if you mess up Twitch. No, don't worry about it. Don't worry about it. It's fine. It's fine. Don't worry about it. I don't want to distract myself with stupid things like that. It's fine. As long as chat is fine, everything is fine. I don't need to bother. So I was thinking to get something like this. Like to be more spread out. And I think that's when we'll have this. Actually, yo, no. I have another idea. Look at this. We can do a couple of iterations. First iteration will be spread out and it will remove like this first layer. Second iteration will be not that much spread out and it will remove this layer. It will be more focused here. It will be more focused maybe. And then another iteration, like to have a couple of iterations to blast off like 20 rays and then to blast off again 20 rays. Probably. Maybe try launching rays around TNT and then launching other rays that are randomly rotated. When the issue persists in some way, 20 races. Bro, we're not doing 20 races. We're doing 200. How many were we doing? We did a lot of race. Yo, what's the maximum race we can do? What's the maximum race we can do? Here we were doing 100 race. Let's do 1000 race. Let's do 1000. Let's do 1000. And let's test it out. The game will explode. Let's test it. 1000 race. Yo, this is this is good creator. This is good creator. We just needed to increase the race. Bro, but that's a huge crater. Yo, look at the crater. 40,000. Okay, let's do 40,000. Yeah. Bro. Yo. Yo. That's a good crater. Yo. Yo. I like this one. I like it. Yo. Let's do it here in the caves. Here, let's do it here. Okay, now we're here. And okay, and now let's right click it and see what happens. Yo, look at this crater. This is like 1000 rays. Yo, that's cool. TNT animations and sound. We'll see about that. We have a limit of 3 hours. We'll see what we will prioritize. Yo, this is cool. So let's increase the race. Let's do 40,000 race. Let's do 40,000. Chat, do a vote if the game is going to break. Will game break on 50k race? Yeah, I did a poll. I did a poll. Will it break on 40k race? What do you guys think? I'm curious what you expect. Over 1 million radius, bro. Okay, let's. What do you guys think? What do you guys think? Will it break on 40k? No. That's why. No. Yeah, okay, let's see what happens. 40k race. Let's see what happens. Okay, if I right click, 55% expect when I right click the game will break, and 45% expect the game will not break and we will have an amazing crater. Okay, let's right click it. Bro, what happened? Bro, oh, whoa. What happened? We're going up. I need to see what happened. The game did not break. But the physics, the collision broke. The physics broke. Let's go up. I want to see the crater. I want to see the crater. Bro, what happened? Yo. I was not, bro. Is this 40,000 race? Let's click it again. The game just freezes. The game just freezes. Okay, chat, what number do you expect the game to break? What number do you... But a reasonable number. It needs to be reasonable. What number of frames do you expect the game to break? Needs to be a reasonable amount. $1 million? 1 million raise. Half a million? Okay, let's do half a million. Let's do half a million. Let's do half a million. And here the journal showed me you can do this. Like it was something like this. This. You can do this, and this makes the number easier to read. The journal showed me this when he reviewed the TNT project. Let's test it. Let's test it. Will game break with K race? Okay, we did another poll. So now we're doing half a million raycast. Let's do half a million raycast. Will the game break when we right click this TNT and have the 50, like half a million raycast? Will, oh, bro, almost everybody thinks the game will break with half a million raycast. Almost everybody thinks it will break. Okay, let's do it. Let's do it. So more than 60% expect when I right click the game to break. Let's see what happens. Okay, the game freezes. The game freezes. Let's see if it will actually execute this. This is half a million raise. Let's open task manager actually. Not responding. It's not responding. Oh, bro. Ah. Oh, there's a limit to the length. There's a limit to the array. But it didn't broke. There's a limit. Yeah, that's why the crater is small. Let's increase the distance. Let's increase the distance. Let's increase it. Let's increase it. Let's increase it to like how much? Like 10? It was, the length was limit of 5. How much should it be? Like 10? Remove the limit, bro. There needs to be a limit. 1500? 50? Okay, let's do 50. 50 is reasonable. 50, guys, 50 is reasonable. And let's do it again. We'll have a bigger crater now. We'll have a bigger crater. That's why the crater was always small like this. Okay, I right-clicked it. And let's see what do we get. Game is not responding. CPU usage is at about 4.4. The RAM is 1 gigabyte. It's like that always. It's nothing different. And nothing else changed. GPU 63%. Not that big of a deal. 3 gigabytes of the memory. What about the RAM? RAM, it's fine. CPU, CPU is fine. Yeah, it's still not responding. It's not responding. It's still not responding. The stream lagged when you clicked for me. Did it crash now? 3-minute lag spike. We need to see what happens. Multi-threading would be insane with this. Probably multi-threading would be cool. Yeah, guys, we just need to wait 5 business days until we see a result. Why don't you use Linux? Because for making videos, it's easier with Windows. Is this good? My PC have 78 while watching YouTube and only have Opera GX. Why are you launching the race on the CPU? Oh, because all my data is on the CPU. All my data is on the CPU. Like, what do you mean? Guys, will this actually do it? I did an SSBO for when the TNT project was everything on the GPU when I used compute shaders. But here I don't want to bother with SSBOs. That's a necessary complication. CPU is not being fully utilized because the program uses only one thread. How long the game will not respond? I don't know. My PC costs temp only, YouTube open 70. So we have to see 50 blocks crater from... You have to wait over a year. So we'll finish just a matter of time. Yeah, but how much time? How much? Look at it, bro. We're not using the whole CPU. We're just using 8% of it. Bro, because we don't have multi-threading. If we use multi-threading, this will be like 10 times faster. It would be so much faster if we used multi-threading. Gotta give it more threads. I want... damn it. I'll give it a little bit more time. Guys, do you think this will finish at some point or not? What do you think? If not, we'll just close it. We'll just close it if not. I don't think so. Oh, bro. Bro? Where am I? Where am I? Yo, what? Why is my position here? The spawn is at 0, 0. Why did I teleport? Negative X and negative Z. So we need to go in this direction. Yeah, let's go back, man. Why? Where did we go, man? Thankfully, we have the coordinates in the debug menu. Thankfully. Yo, what happened here, man? Yo. What happened here? What happened? Bro. What's this crater, man? What happened here? Oh, this is the TNT. Oh, the mesh hasn't updated, probably. I don't know. But that's the TNT. That's the TNT. Bro, look at this crater. Yo. And look at how it's a perfect circle. This is a perfect circle. But this is not a chunk boundary. This is something else. Like, for me, I use subchunks, which is like 16 by 16 by 16. Let's start removing. Oh, all of these meshes here, I cannot move them. There is no blocks here. Here, all of this is just left out mesh that stays here. It needs a block update. Let's actually start placing blocks and see what... this stays the same. But here... okay, we removed it. We updated this. We updated this. We cast an update here. Here as well. How are we going to reach this one? We need a bigger update. This is just so I can issue an update for the subchunk. Okay, we updated this one. Oh, we have one more. This one. Okay, because my code for like oh yeah, maybe there's a bug. When you remove the last block, it doesn't remove the mesh. Yeah. Look at how the mesh stays. When you remove the last block of the subchunk, the mesh stays. Okay, guys, we found a bug. We found a bug. Yeah. We found a bug. Yeah, we found a bug. But this is the crater. And for some reason, it stopped here. For some reason, it didn't go past here. L rays, broke rated, ghost blocks. How would it look on such big radios with like 16 rays? Something feels wrong when I see this. Can to handle... Do you have that it's only loaded in front of you? I don't know, guys. I don't know. I don't know why the rays didn't make changes here. Because there is no difference between this side and this side. There is... Oh, wait a minute. Is this like negative coordinates? No. There is no difference between here and here. There was no difference. There wasn't a difference. I don't know why it happened like... Like the only difference is like maybe here was the TNT. And all the ray directions just decided, that's unlikely. You inspired me to make my own Minecraft clone in Python. Thank you, man. Maybe only raycasting positive. Sample the other chunks properly, please. Anyone wanna play? Other half was protected. You were faced back that spot, so that's why I wonder maybe the terrain weren't loaded. I don't know, guys, but this will be the new thumbnail. I think. Because this is like... Yeah, something like this, man. Like here. Yeah, something like this. The particles are falling down. Yeah, this is a cool shot, man. I'll update the thumbnail and we move on because we have goals to achieve. We cannot play around for forever. We need to achieve the goals. Where is chat? I lost chat. Here is chat. And here the particles falling down. Look at them. How they fall. Yeah, they're very cool, man. The particles. But let's not get distracted. So the game didn't break, it didn't like crash, but it managed, it created this crater, which is fine, and we'll lose this world once I close the game. We don't have saving, we'll lose this. So guys, look at it for one last time. We'll have to close it. Sadly, we need to close it. Yeah, let's close it. Bro, that was wild. That was wild. Let's go back to the TNT. Here, instead of like 500,000, let's do again like 1,000. Let's do 1,000. Let's keep the length to be 50. Let's keep the length. Why do you replace dirt with grass block? I had replaced it, but it was in a previous commit. Let's test now a much simpler TNT. Okay. No, let's bring back the distance to be like 5. Let's bring it back to be 5. Let's bring it back to 5. Sure, now this is completely fine. I'm completely happy with this, man. I'm happy with this. Like, this is good enough for me. For me, this is good enough. It's good enough. So what now? Now, we have a couple of options. We can make it interact with other TNT, or we can make it like have a time where it prepares here to like start to become an entity, to go down, to collide with the world, and after like 10 seconds to explode. Crater too big. It's fine, it's fine, it's fine. It's fine. We can always like lower it later on. Some grass floating. Because I haven't made an update when you remove the block under it to like remove this. It's fine, like I don't care about this, like it's fine. We'll see what we're going to do. So what now? We have like, yeah, like I said, we have two options. One option is when this explodes, to explode this as well. No. This would be the wrong approach because the explosion would happen instant. No, that's a bad idea. We need to make the TNT an entity. We need to make it an entity. And what does that mean? That means to make it like this, where it can fall down. Here it becomes an entity and it prepares for a little bit, and that's when it explodes. That's what we're going to do. We'll make it an entity. So we are basically, this is my idea. We will just remove the block. It gets deleted instantly, deleted. And on its place, an entity gets created. An entity gets created. Yeah. Why are you using rays for the TNT? Because I think Minecraft does it like that. And if I don't use rays, chat will obliterate me. Chat will destroy me if I don't use rays. Right, chat? Chat, right? Back me up. Okay, let's move on. So now it just instantly makes this destruction. Instead, we'll make it an entity. We'll make it an entity. We'll make it an entity. So that's the next step. That's the next step. Particles looks like now. Ah, this is the particles. This is particles. This is particles. I really like the particles. And I'm happy that chat suggested we do particles. Like, chat always knows what's the best next feature. I don't know how chat does it, but chat always knows what's the best feature to implement. Like, I'm very happy we did particles. That looks very cool. It was worth it. And now we're doing TNTs. And I'm also happy we did TNTs. Like, this is cool, man. This is cool. I'm happy with chat suggestions and votes. Don't stop using rays. Chat knows everything too because of it's a group of people. Once TNT, try adding the hand. That's based on chat to decide. Okay, let's make it an entity, the TNT. Let's make it an entity. Let's make it an entity. Oh, this is awesome, man. This is awesome. TNT uses rays when explodes. Perfect. Perfect, man. I'm really happy with this. So let's make it an entity. When we right click it, it should disappear and create an TNT entity. We need to create it as a separate class, actually. We need to create it. So here, let's do TNT entity. Header file. TNT entity. Or just TNT. I'm not sure for the name because I wanted to name it to be like called TNT class. Like here, a structure TNT. I wanted to be called like this, and here to be like public entity, like this. But we already have a TNT structure. Include entity. We already have a TNT structure, so let me change it. Where in here, let's rename this. Let's rename it to be TNT block. I don't want the entity to be called TNT entity. So this will be TNT block. This is better. TNT block. And here, where was it? Here. Let's rename it to TNT. Rename it, and this will be TNT. Perfect. Perfect. Call it falling block and then make it prime TNT inherit from falling block. Maybe, but that's for that would be for later. That would be for later. Yeah, it's fine, guys. We don't need to like. It's fine. It's fine. It's fine like this. That doesn't matter that much. If it causes problems, future me will figure it out. Like for now, it's fine. And let's copy from the player a few things. Yeah, we don't need which direction. We don't need front right up orientation. We don't need this. And we don't need yaw and pitch. We don't need that. We don't need this. We don't need this. We just need the functions. The constructor and the update. That's the only thing we need. The only thing we need. Here, let's add them like this. It says TNT, and let's create the CPP file. And here include TNT, and let's implement them. Did it happen? Okay. Don't worry about it. Here, let's refresh CMake. And let's try it again. TNT here, let's implement it like this, and here the update. This is the TNT update. We need to update the position. And here we'll actually Mojang need to hire you. For Mojang to hire me, I need to send the CV. Mojang will not hire me just like that. I need to send the CV, and I'm not sending one. So Mojang will never hire me. It's very simple, man. It's very simple. Here, particle, we want this, all of this we want. Oh yeah, we need the position as well. We need a position. Like in the constructor, to take in a position. So you are the only one that can fix Bedrock. Thank you. I think the reason they have so many bugs in Bedrock is because they use AI. I'm almost certain they use AI in the code generation. Like they're trying to optimize it. Like that's allegedly. I don't know. I have no idea. Like, guys, it's allegedly. I don't know. This is just a guess. But they have so many weird bugs, man. They have too many bugs for not to be true. They have too many bugs. Let's go to the TNT. And here. And this is the position. Are you serious? Bugrock was like it forever? Then I can be wrong. It doesn't matter. It's fine. I can be wrong, guys. Like, it's completely understandable if I'm wrong in this guess. It takes in a position. Sure. It takes in a position, and here position position equal now let's just make it a copy. Let's make it a copy, and here we'll just issue the TNT. We'll issue to be like 0, 0, 0. Okay, so let's copy the particle. Like this. Copy the particle, and we go to the TNT here. So what do we do now? Scale, we don't need this. Velocity, noise, we're not using this, and collision box will be from 0 to 16, it will be a full block collision. It will be a full block. It will be a full block, right? I'm not doing anything special. Let me think about it. So what now? We need to draw it. So we need a method for drawing. Void draw. And here we need a mesh, right? Question mark, mesh. Mesh, we need a mesh. A model too as well. We can do model or mesh model. Yeah, we'll see. We'll see. We need to generate it actually. We need to generate it. And we need to... How often do we need to generate it actually? No, we only need to generate the mesh once, and we'll just change. We'll just use a matrix transform. It can be a model as well. What's the difference? Difference is that model, you give it a bit more information. Here, if it's a model, you give it like more data, so that you don't have to look for it every time. So here in the constructor, let's create that model. Let's create it. And how would we create it? Let's look from the GUI for inspiration in the item slot. Generate model. So we get the block, mesh context, we generate the mesh. Here is the mesh, we upload the mesh. We set the model, we set texture and shader. Okay, perfect. That's what we're going to do. That's what we're going to do in the constructor. Here. So we need the memory, we need the block. We need the block, we need the block factory. We need... What do we need? We need the world. Include. We need the world. And here, this will be the... Just the TNT. This will be the TNT block. Will this have an event plugin system? What do you mean? So what now? What now? Yeah, the draw function, when we draw it. Here, when we draw it, where is the TNT? I pay money. What do you mean? The way he said it was funny. Draw method. Here in the TNT, let's create it. Void TNT draw. And here we need to do draw model. That's what we need to do. So here we use the model. The position is the TNT position and no coloring tint for now. But why is it complaining here? We need to import something. We need to import here, maybe include Raylib. Why is it still like this? Though, maybe something else needs to be here. Oh, scale. I'm dumb. And here white. And here white. Sure. Okay, that should be enough, actually. Actually, that should be enough, I think. Position should be... no, it's fine. It's fine. So, now, this is the game plan. Now, when we go to the... When we go to the, where is it? TNT block, and here on right click, on right click. We need to create the entity. For now, we'll not explode. We'll not have explosions for now, just to focus on the entity. But we will destroy this current block when we right click it. And on its place, we'll create the entity. But we need, let's have a reference to all the entities. They should be in the, let's say to be in the world. Let's include them. Include, what should this be called? I might be the only one who's watching this without understanding anything. You're not the only one. Sometimes I also don't understand what's happening, which is pretty often. We need to include here the entity. Here we need to include the entity. But if you use AI, the moments where you don't understand what's happening increase drastically, like 100 times. The more AI you use, the less you understand what's happening. Here, what are we going to do? We want, okay, a vector. We'll do a vector of entities, right? But then we'll need to call the draw method, right? So we need a virtual method. We need to call the draw. We need virtual void draw. We need a draw method. And let's have it be no implement. Does every entity need to get drawn? Question mark. Because we can have here a model. For example, the player doesn't have something like this. The player doesn't have a draw, I think. Because it doesn't have a model. Yeah, it doesn't have it. But it would have for the hand, maybe. But it would be different implementations. Oh yeah, let's do it virtual. Let's do it pure virtual, actually. No, let's keep it like this. And let's override it. Let's override it in the TNT. Here we override it. So that inside of the world, we can just have here a vector of std unique pointer of entities. I think we can manage with a unique pointer. Unique pointer is like a fancy pointer. I hope the people that are wondering, I expect them to know what a pointer is. So unique pointer is like it handles deletion automatically. It's like having a garbage collector. When it's out of scope, it gets deleted automatically because this is memory on the heap, which is like the RAM usage. And that's how you get a memory leak of 40 gigabytes. It's when you don't delete your pointers. And this one will handle itself. And here we have entities. So let's make a function where we add an entity. Right? And how can that happen? How would that happen? Let me think about it. Yeah. Oh, I get it. We'll use a template. So here we do static void add entity. Here we'll add an entity, and this will be a template type name T, which requires what a base, what was it? Base v, what was it? Is base. of v was something like this. And here the entity, and here t. So something like this. Let's look up the application. I don't remember what it was, or like what was it? Where was it? The layer stack. Here, this thing. Require, yeah, this. Oh, std is base of, yeah, is base of here. Here is base of entity. It's base of entity, and we need to include it. Entity. We need to include it, and here we need to define it. But why is it inline? Why does it want it to be inline? Let's make it inline here then. Let's make it inline here. What was it complaining about? Not found. I want to do it in the CPP. In world H. Copy signature of entity to clipboard. Yeah, let's go to the CPP. So where is this? This is in the world, I think, question mark. Here, yes. And here, okay, here. This is what I wanted. And I didn't want this to be inline. What's it complaining about? It's incompatible with function. Do I have to put the template just here? Or it needs to be here as well? Does it need to be here as well? Okay, and here it's inline. I don't want it to be inline. Okay, it's perfect now. It's perfect. So, and here we do, what do we do? What do we do here? In here for entities, data, or world data entities, we need to create it actually. So the entity, we need to create it, and we need to give it a position. Vector 3 position. We need to give it a position. Const. We need to give it a position, and here we give the position, and we need no, actually we need std unique pointer of entity actually, right? And here entity equals std make unique, right? And here of type t, and here we give the position like this. Perfect. And this should push the, oh, and here we need to push it. Std move entity like this. This should be it. And let's actually run it to see any compilation errors. Template function, and in the header implement C++. It will work. Linker will get math. Hopefully not. Let's actually use it and see if it will get math. Let's actually try to use it. If it's a problem, we'll do it as an inline function. We'll do it as an inline in the header file. It's not that big of a problem. So now this is for adding a TNT entity. So let's use it in the block here. On right click here. And where is the, yeah, this is the starting point. We'll spawn it here at the starting point. So world at entity TNT at entity with position the starting point, and we need to include TNT like this. Okay, let's test it out. Oh, and we need to draw all the entities. We need to draw entities. So here do we have like a static void draw And let's implement this. Come on, work with me. Okay, I need to do it manually. TNT here. Not the TNT, the world here. Like this. Here we need the world. And when drawing, we'll just go over the entities. So for auto iterator equals world data entities begin, and if iterator is not the end, entities end, and here plus plus iterator. And for all of them we do iterator second, or does it need to be like a reference? I don't know, man. What does it need to be? Like I want the second? No. Draw? No. What's the iterator? This should be std vector of std unique pointer of entity, and this should be iterator, right? This should be iterator. Yeah. And here what do we have? Not much. We don't have much. I want access. Oh no, we're iterating over the vector. Okay, I'll do what you're suggesting. For auto with reference entity world data entities. Hello. What's up? What's up? An entity draw. Okay, thank you, man. Thank you. You're my AI. Yeah, chat AI. I have chat AI. And so what now? We need to call this function. Insane for loop. Let's go in main. Thank you for the follow. Let me think about it. And in the game layer, where we when we draw, where is on render here, or where? Yeah, here, before we enable color blend, we'll do world draw. Okay, let's test it out. I come from bug video. Which bug video? Which bug video? Oh yeah, the linker, like somebody in chat suggested, the linker had issues. Yeah, we need to move this. Chat was right that the linker would complain. Chat was right. Yeah, we need to do it here. Here. Yeah, chat is always right. Not always, but most of the time. This should be static. Static void at entity. Perfect. And inline. Can we do it inline? Yeah, but we have an issue. It doesn't know what the world data is because it's in the CPP. It's in the CPP. It's in the CPP. Yeah, that's why I wanted to do it separately. That's why I wanted to do it like that. Oh, but can we have the type name just be in the CPP then? Can the type name be just in the CPP then? Can it be just here? Like this? But then it complains it's not like the class. It's not like in the header. But I want it to be here because I want access to world data. Because it's here in the CPP file. It's a static, because the world is like a singleton. We probably would, yeah, okay, we can do it differently. We can just, it's not that big of an issue. Add TNT. Like, it's fine, guys, it's fine. Add TNT. We can just do that. It's fine. It needs to be in, it doesn't need to be in a singleton. Guess what? Are you going to rewrite the titles? That's a big ask, man. That's a big. Have you already learned? No, I'm just using Raylib. I'm just using Raylib. So this should be the TNT, and it's imported. We'll probably make some kind of a manager class for entities. That's a different kind of singleton. That's a bit different, but this is fine. Let's go to the TNT block here on right click. And here, this is add TNT. This is add TNT, which is fine. What do you think about performance? Performance is fine. I'm happy with performance. For me, it's fine. For my use cases. Okay. Now, we are implementing the TNT. We managed to make it explode on right click. We managed to make it explode on right click, but it instantly exploded. And now we made it into an entity when we right click. So what I expect when we right click is this block to fall down to the ground and to see it here. Why did it spawn there? Why did it spawn here? Oh, we're not updating it, and we need to, yeah, okay. The spawn position is wrong, and we're not updating it all the time. But we're getting there, so when we spawn it here, what do? I use the block origin. Yeah, let's just use directly the block origin. Position details, block origin. Let's just use the block origin. And we need to update them. Here, let's make a function called update, and let's implement it. Here. And here, this is, what is this? This is update. And here, update. And we need to implement this function for the entity. Where is the entity? Here. We need to make it a virtual update. Like this, virtual. And for the player, this update is an override. And for the TNT entity, an override as well. Override, and we need to call the function. Let's call it in the on update. Let's call it here. Let's just call it where. We can call it at the end of on update here. World update. We can call it here. And let's test it out. I'm going to create Minecraft clone using Unity. Good luck with that. Hopefully you have a fun experience. Now, I expect on right click this TNT to fall down. I expected it to fall down. Where are you going, man? Where are you going? Bro, fall down, not there. Bro, where are you going? Where are you going? You ran away. Bro, come back. Bro, come back. Let's spawn a couple of them. Oh, they have random direction. They have random direction. And they just fly away. They just fly away. Where is the TNT? Update position. Oh, the velocity. We pick a random direction for the velocity. We don't need to pick a random direction. We don't need to do this. Here velocity. We just set velocity to 0, 0. Right? We set it to 0, 0. Collision box is fine. And we want here gravity. We want gravity. So let's copy from the player. We want gravity. We want delta time. Here gravity. Where is gravity? Yeah, here is gravity. Like this, like this. Now it should have gravity. Now it should have gravity. Explosion direction is fine. We just change the velocity. That's your explosion direction. So when I right click this, I expect the TNT to fall down. Yo, it fell down. Now let's make it collide with the world. Let's make it collide just like the particles. Just like the particles. Here. Handle terrain collision. Okay, we just do the same as the particles. So where is the TNT here? Update. Like this. You also wait for 30 minutes. What's new? The TNT from a block changes to an entity. Like this. So we expect it to fall down and collide with the world. Yo! 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 Yeah! Yes! Now let's make it flash. Like, Yo, what's up, Wix? What's up, Wix? Only Wix can send links because he is VIP on Twitch. Only Wix can send links. Okay, it becomes an entity. It becomes an entity. Perfect, man. Perfect. Perfect. Now we need to make it flash colors, just like in Minecraft. We need to make it flash colors here. We need to make it flash like this. We need to make it flash colors. And how does this happen? Like an overlay. It's an overlay. Why is chat changing every day? I'm just experimenting, don't worry about it. I want to see what fits best. Because previous one, somebody said it was too small. You said that. Thank you, Preston, then for suggesting it. It was helpful. It looks like when you ignite it, push itself a bit away from blocks around it. You got 2 monitors? Yeah, I have 2 monitors. Increase the alpha on the texture. To increase the alpha? I just want to make it flash the color. Yeah, this is cool. This is cool. Yeah, that's cool. Yeah, I like this. I like this. Yeah, this is cool. We need to make it a face reveal, bro. Just look at my profile picture. How should we make it like this? How should we make it change color? From Bulgaria. we need probably an overlay, color overlay, I think. Like we have an overlay and it's like just a regular white color. Let me think about it. How should we do this? How should we do this? I think like they used a certain texture. Minecraft, I think they used a certain texture. I think they had an additional texture. I think that's what they have. I think they have an additional texture for this. That's white and red. I'm pretty sure they have a white and red texture for effects. Effect. No, I'm not replacing the texture. I'll just use two textures. Item map. Where? Oh, here they have a white texture. They have underwater texture. That's helpful. Mob effect. Painting, particle, trims. Yeah, we'll figure it out. We'll figure it out. Yeah, so we are adding TNT. We are making them into entities. They collide with the world. I would like to make them like change color to indicate, to have the indication, but we'll do it in like a minute. I need 2 minutes. I'll be right back. Yo, I'm back. So, we have two options. One option is to make this like flash, to indicate it's about to explode. The other option is to just directly move on and add the explosion and the interaction with the other TNT. That's the other thing. Okay, let's do an attempt to make it indicate it's going to explode. Let's do an attempt. If it doesn't work out, we'll just move on because we have a time limit. We'll move on. But first, let's make it like indicate. I need to mute a couple of guys. All right. Yeah, now it's fine. Now it's fine. Guys, that's the only rule to speak in English, bro. That's the only rule. I just did a 1 hour mute, so it should be fine. So how are we going to do the indication? How are we going to do the indication? I don't want to open up render doc. Here, overlay. Do they have this? Overlay. Is it called overlay? I think it was like, oh no, I should have it. I should have this texture. If I search it up, so it should be in my voxel engine, right? Should be the voxel engine. Should be the voxel engine. And resources. I think I've used this before. Assets. Textures. Oh, here I use the texture pack. The blocks. This is the blocks. But I don't see the overlay. Yeah, this is with the TNTs. Yeah, this is with the TNTs. Yeah, this is my 10 million TNT explosion. And here I managed to do the overlay here, but I forgot how. Let's check it out, actually. This is my old... This is my old 10 million TNT project. And here I should have the color switch. I should have it somewhere. But where? Yeah, let's look at shaders. Compute shaders. Draw terrain. Or this. Ah, this is global include. TNT instancing. And so what texture do... Oh, color overlay. This is it, color overlay. Oh, I changed the... Is that it? Just changing the alpha. Was that it? And here geometry shader. And here... it's a mix between the texture, the color overlay. Okay. Oh. Okay. I get it. Oh, yeah. The color overlay is white color. And here we use a mix between them, depending on the overlay alpha. Yeah, I get it. Okay, that's how we do it. I get it. Yeah, and we just change the... Yeah, okay, I get it. Yeah, I get it. I remember. Okay, let's make the TNT flash. Let's make it flash. So we need to change the alpha here in the update. We need a color overlay to change this color overlay. To change this between... Yeah, let's change it here right now to be 255, 255, 255, and here to be like how much? How much to be? Should be 0.24. Let's see it in 0.20 by 255. So 62, 63. Let's do 63 alpha. Let's do 63 alpha and see what do we get. The TNT will not be flashing, but it should be like with the proper overlay. But let's see. Let's see. Let's see. Okay, it is ignoring the alpha. It's ignoring the alpha. Preston, you're getting like 7 days timeout. Okay, I think 7 days is too much. But I already clicked it. Wait, bro, Preston. Sorry, Preston. Okay, one day. You're getting 1 day. Oh, why did it ban you? Like, bro, I picked timeout. Okay, I'll figure it out off stream. I picked timeout and it banned you. I'll figure it out off stream. Okay, the outline. The outline. Here we need to change the shaders. Because right now when we right click the TNT, it doesn't change colors like this. It doesn't change color like this. And that's what we're trying to do. We have the idea how to do it. I need to change the textures, the shaders actually. Excuse me. Shaders. So we need to change, let's do the terrain fragment shader, right? And here we have the, which one is it? Color diffuse, fragment color. Yeah, we have fragment color, sure. Let's delete this and here do final color equals the mixing between them. Mix, no, we can do, it should be like this. Color equals mix between final color RGB and what do you call it? The fragment color. Between the fragment color and it's using the RGB and it's using the alpha of the fragment color as here, the alpha for the mixing. And here final color equals RGB equals color RGB. Can we do this? Or will it fail? Yo, what's up, Maskele? Clay, sorry, Clay. Sorry, Clay. Bro, what happened? I think we need to swap them. I think we need to... Bro? Oh, yeah, failed. It just failed. Undefined variable color. Oh, yeah, here it's vector 3. It's a vector 3. My bad. Okay. Bro. Final color in this. Oh, it should be maybe like this. Maybe to swap them. But now it's a bit different. We'll see how I did it in my other project. How did I do it? So how did I do it? Yeah, I get the color from the texture and I set the RGB to a mix between the color overlay RGB, the texture RGB, and the color overlay alpha, right? So here, the color is mixed between, yeah, to swap them, I need to swap them. Yeah, between the overlay, the color overlay, the final color, using the alpha. Yeah, that should be it, right? So yeah, final color RGB, like this. Color diffuse, we'll do it here actually. Or we can do something else. We can do here with the texel. We can do it directly on the texture. And here, yeah, like this. Let's see what happens. Looking good. Falling prime TNT. Yeah, bro, we're pretty close, but this overlay. Oh no. Wait, does it have an alpha? Yeah, it has an alpha fragment color. It has an alpha. So we mix between them. Yeah, we're getting here. We're getting the texture. Sure. And we are mixing between the overlay and the texture. Oh no, this should be the texture. Should be a texture, my bad. And here we use the alpha of the overlay. Let's test it again. Let's test it again. Yo, it's lighting up a bit. Yeah, it's a bit brighter. Yeah, it's brighter. But we are losing the grass. Oh no, it's fine, the grass actually. It's just in the inventory. We need to figure out what's wrong, but it's fine. Our focus is the TNT. Our focus is the TNT. Let's go back to the TNT here. Let's increase this to be like, or decrease it to like 30, 33. We need to make it flush. We need to make it flush. It's still kinda... It's brighter for sure. Sure, it's brighter. So this color overlay is the maximum, 255 alpha. So 255 alpha, it's using just where is the shader? Where is the shader? Where is the shader? Terrain fragment. When the alpha is maximum, it's using just the texture itself. But if it's like 0, it should just use the white color. It should just use the white color. Oh, wait a minute. We can... Will for sure take your sanity. I'm back. Holy Twitch chat looks like symmetry. Because I muted a couple of guys there. Don't worry about it. Yeah, let's do the alpha to be 0. Let's do the alpha to be 0. I want to see what happens. This is just so we can make it like a flash. Just so we can see it flash. Yo. Okay, this is when it's 0. So when it's 0, it should be... Where is the fragment shader? When it's 0, the alpha, this RGB should be just the white color. Should be just the white color. And here we multiply it by this. Here, let's test it here by putting a 0 manually. I am not trusting it. It's actually doing its job. You're the goatest streamer. What do you mean goatest? Thank you, man. Thank you for follow. No, for a highlighted message. Okay, now it's completely white. Yeah, this is what we want. But it's not using my alpha. It's not using my alpha. So let's look at the vertex shader. So let's look at the vertex. It's getting the color. It's from the vertex color. Sure. So the TNT here, it's ignoring this 0. It's ignoring it. When we draw, let's look at how it draws at Raylib. This is the tint. And here draw model EX. And here, how do we use this overlay? Okay, we divided by 255. So 0 divided by this should be 0. So for now it's fine. And that's it. Okay, so through your streams are surprisingly interesting. Thank you. Thank you for that. I try my best. Why is not the alpha 0 when I set it here? Here, this is how I draw the TNT. It uses the atlas and... Bro! Item slot shader. Terrain, bro. Terrain shader. Dude. Terrain shader. So it's using item slot shader. So it's using the wrong shader. Excuse me. Excuse me. terrain, right? Terrain, and should be this. Let's look up terrain. Yes. Yeah, oh, I get it. Yeah, I get it. Yeah, the terrain actually uses lighting vertex shader and fog fragment shader. They use different shaders. And so the item slot shader should be fine actually. Yeah, it uses the terrain fragment shader. It uses the terrain fragment shader. So it's using the proper one. Yeah. No, it's fine. Let's get it back to this. And here, this should be like 0. Here, let's do vector 3 color. Close this to 55. 0. And here, color. Like this. Oh, it's a vector 3. Vector 4. What's the issue? Oh, it needs a color. A color. Like this. How do they initialize colors? How do they initialize them? How do they initialize colors? Maybe in game layer header. Yeah, here. This thing. So let's go back to the TNT. Like this. So we need here to be 255. 255 and here 0. Here 0. Let's test it. Why do you need 4 color values if RGB is only 3? I'm using the alpha. But it's not actually using it, the alpha that I'm expecting it to use. It's not actually using, because I'm giving alpha of 0. And when I manually set it here to be 0, the alpha, when I manually set it to 0, it's completely different result. It's completely different result when I do it manually from the shader. Yeah, it's completely different. Yeah, look at it. It's using some kind of a different alpha. Or we can set it to 255. Maybe it's like the opposite. Let's set it to 255. Yeah, maybe it's inverted. No. This is like, it's the same. Whether it's 255 or 0 is the same. For some reason. I don't know why actually. I'm not sure why. That's very weird. It's not using the alpha. Yeah, it becomes... no, it becomes a bit of a different color because I'm using a different... it uses different shader from the rest of the terrain. It uses different one, but I have an idea. Let's look at item slot here. Let's use the terrain vertex shader as well. The terrain vertex shader, just in case. Just in case. Oh, it's still the same. So it's not this the issue. The fragment shader. Yeah, here, look at this. I get the texture. Using the texture coordinates, I get the texture. And here we don't need to look at this. Here, the texture itself, I do a mix between the overlay and the texture colors. Using the alpha of the overlay. And here if the alpha is 0, we'll get the whole block will be white. If the alpha is 1, the whole block will be TNT. That's the mixture. And if it's half, it will be between the two. The problem is it ignores the data I give it. It ignores it. Wait a minute. Wait a minute. Maybe it's the uniform, the tint, the color tint. Maybe it's the uniform. Yeah, maybe it's the uniform. Maybe it's the uniform. And this should be the frac color. Yeah, my bad. This should be the frac color. I think they are swapped. I think they should be swapped. So, what now? Now we test it. And what am I using as a value? I'm using 0. So now it should be completely white. No, alpha is not the first. It's not the first. Okay, we did it. We did it. Now let's set it to 65 or like 63 alpha. So now it should be mostly white color, and a little bit you can see the TNT. Yeah, we'll make it blink. We'll make it blink. Okay, look at it. This is the overlay. This is the overlay. Now let's make it blink. Let's make it blink. Let's make it blink. So let's let's move actually the color outside to be here. Let's make it be here. And here let's set it like this. Let's initialize it here. Let's initialize it here. Color. Like this. And here by default it's 255. And here in the update we'll change it. And how often do we change it? How often is the blink? How often is the blink? Let's do here float last color update. Let's do last color update. And here we'll do a last color update equals get time. 3 seconds is too much. It's too much. But here in the update we'll do if get time minus the last time we did an update to the colors. Last color update will be get time. So what do we do here? We update the color. So if color alpha equals 255, color alpha equals 63. Else color alpha equals 255, like this. And we use it here. This should do it. This should do it. This should make it blink. Oh no, that's wrong. We need to make it if it's the time that has passed, if it's less than 1 second. So it will blink every second. If you upload Minecraft clone GitHub with the textures. I don't know, man. And here we go. Look at it updating. Why is it going crazy like that? Bro, that's not 1 second, that's less than a second. That's less than a second updates. Okay, let's make it 10 seconds. I don't... Okay, let's do 3 seconds. Oh no, if it's more than a second. If it's more than a second. If it's more... That's 1 picosecond. Let's see if it's more than a second. Bro, that's an eternity. That's an eternity, man. Let's do 0.5. Half a second, or like 20.25. 3 to 5 business days. You can share game. I cannot share anything. Yo, look at it. Now it's a bit better. Yeah, now it's a bit better. Now it's a bit better. Too fast? Ah, it's fine, man. It's fine. Well, how is your stream going? It's going good. We make good progress. Now let's make it explode after like 5 seconds. Let's make it explode after 5 seconds. Let's make it explode. Let's make it explode. So, how are we going to do it? We will keep track of it. Float time created. When we created it. And here, time created. This is when we created it. And here in the update, if and here, if time updated, time created, if 5 seconds have passed, we will nuke it. We'll nuke it. But this TNT also should get destroyed. It should get destroyed. Now we can change the scale then. We can change the scale. We can play around with the scale. We can play around with the scale for the... Okay, let's make it after 5 seconds to create the explosion, but also we want... What do we want as well? And we need to be fast because we're running out of time. Chat. We're running out of time. We're running out of time. We want after 5 seconds to create the explosion and to delete this entity. How can we delete this entity? How can we delete it? We need from the world, we need a function world delete. No. We'll create in the entity boolean mark for deletion. Bool should delete like this. Should delete. And by default is false. By default is false. And so in the world, when we update here, we'll iterate. What we need to remove them. We need to remove them. How? Let's do a for auto iterator equals world data, or like begin world data entities iterator different than world data entities and plus iter, and here this should be at the end. Should be at the end. This should be begin. And what's the issue? Show a value of reference to non-cons, cons, so maybe const reference. Sure. So what now? What's up? I'm also Bulgarian. What's up? We want to check if we should delete it. Like, do I need to do like this? And should delete. If we should delete it, we do, what do? We do world data entities erase the iterator like this, like this. Else, oh, and here we don't need to do plus plus. And here we do iterator plus plus like this. This should remove those that we want to delete, to be deleted, right? So what now? So now in the TNT update here, we want to delete it. Should delete equals true, like this. And it will get deleted in the next frame. But let's see it in action. So I expect now, after 5 seconds, the TNT to get deleted. And if that works, we'll make it explode. We'll make it explode. So 5 seconds and it should remove itself from here. Okay. Yo, nice. Now let's make it explode when this happens. Here, let's make the explosion. So block on right click. Basically here all of this. Like that. And here TNT update. And here in the update, here we need a position. Position details equals. No, we can just use the current position. No, we can just use the current position. Like this, we can just use the current position. And we do the explosion. And what's this? This is the function. And what's this? This is the if. Like this. Okay. Is everything fine now? Everything should be fine. We need to just test it. But here, let me remove some of these files. Now the TNT block is much simpler. It's much simpler. Okay, let's test it out. Now the TNT should actually work. It should work. Okay. And I'm expecting after 5 seconds to see an explosion. Yo, bro. Bro. Yo, that's a TNT, man. Yo. Okay, I made multiple ones. Yo, look at them go, man. Look at them go. Let's make multiple ones. I'm not that fast. Okay. Yo. Yo. Bro. That's sick. Yo, that's cool, man. Yeah, that's cool. But now it would be cool if the TNT ignites another TNT if it finds one. If it finds a TNT to ignite it, because right now it will just remove it. That would be sick. Yeah, let's do that. Yo. Where should this happen? TNT explodes after 5 seconds. Nice. So here in the explosion, what do we want? Here, when we set the block type to air, we want here before this, if this clone looks awesome, thank you, man. Here we want if the block ID is TNT that we are removing. If the block ID is TNT, we do the same. Like when we ignite it. The same when we ignite it. Like this. And so this should be the current block origin. And we'll set it to be here actually. Okay, this will ignite it. Now we should be able to ignite other TNTs. Scale before explosion. We'll see about that. Okay, let's see if this TNT ignites this one. Yo, it ignited it. And now it needs to wait lower time when it gets ignited. It needs to wait lower time. And when it's already ignited as an entity, it needs to blast off. When it's already ignited, it needs to blast off in a direction. Yeah, that would be sick. Bro, we have TNT, man. That's super cool. Yeah. Bro. 0.5 to 1.5. Okay. So here we can give it 0.5 to 1.5. So basically, let's be able to give it a number. Float time till explodes equals, we'll make it be get random value between 5 and 15, and we divide by 100, right? So this will make it be between 0.5. No, it will by 10. It will make it between 0.5 and 5 and 1.5. And now time till explodes. Let's change the function here. Float time till explodes. And by default to be like 5 by default, right? And we copy it. Here. Time till explode, and here when we create the entity, we'll give it explode. We'll give it to the entity. And what now? And we need here a constructor for it. Float time till explode. We need a constructor for it. And sure, time till explodes. And here we'll make it like this. And here we do this here. Yeah, thank you, man, but don't spam it, because you will get muted. Oh man, don't make me mute you. I muted you for 10 minutes. This is like watching Mona Lisa being painted. That's funny. Here, time till explodes. Time till explodes, like this. And here, by default, 5, right? And here, we do... where do we check this? Time till explodes. Where do we do it? This is it. Time till explodes. Okay. So what now? Now we test it, I think. Now we test it. Now, when we ignite the TNT, it should explode after 5 seconds. But if it ignites automatically another TNT, it will ignite way faster. Okay. So this one will take 5 seconds. This should take way lower. Yo, we did it, man. It's way faster. Yeah, it's way faster. It's way faster. And now, is it possible when we ignite the TNT and if this is ignited to move it away, to blast it off? To blast it off. Is it possible to blast it off? Because this should need to blast off. I don't know who your friend is, but I time out the person who was spamming. Bro, don't worry about it. And it's like a 10-minute timeout. It's like one of the lowest timeouts you can get. So, how should we do this? To blast off this TNT. How should we do this? Maybe to go over all of the TNTs and to see if there is one near it. But if we have 1 million TNTs, if this explodes, it will need to iterate over all of the 1 million TNTs. That's kind of a bummer. That's kind of a bummer. Yeah, it needs to iterate over all of them. So we can blast it off. So it will iterate over them. It will check the difference between their positions to see if there's a TNT near this when it explodes. And if there is one, it will use it will calculate where it needs to blast it off towards. But it needs to iterate over all of the TNT. This clone looks cool. I started posting videos. Good for you. 5 TNT at once. Yeah, let's spawn more of them. What happened? Oh, because when we are adding, the right, because I was doing too many right clicks. Because when a right click happens, that's a separate event. from the main thread, and here it broke the iterator. Yeah, but that's fine. That's fine. Should I do this? Let me do a commit actually. Let me do a commit. TNT ignites neighboring TNTs with lower timer, like this. Should I make them push them? Should I make the TNT explosion push other TNTs? Should I make it happen? I think we can do it. Yeah, let's do it. Why not? Yeah, let's do it. We're over the 3-hour time limit, but I think this will take like how much? Like 10 minutes? 15 at most. 15 at most it will take. Static void. Push other TNTs. And here const vector3 reference. TNT origin. Blast origin. Blast origin. Like this. And so what now? So now we want to iterate over all of the TNTs. And what else? What else do we need to do? Yeah, over all of the entities. We need to iterate over all of them. And we need to get their position. We need to get their position, so we want, what do we want? We want their difference. Their difference equals, what would it equal? The blast origin. Now we need a vector3 blast origin minus the, we don't need to do it like this. We need blast origin minus the entity position, like this. And if vector3, and let's get the length or distance. Let's get the distance equals the vector3 length, the vector3 length of the difference. And if the distance is, if it's less than or equal than 5, we'll change its velocity. Entity velocity will set, what are we going to do actually? We can plus equals the difference. Why not? And let's see what happens. So we'll call this when the TNT explodes. Yeah, here when we have an explosion, where is it? Here. When we have an explosion, but it will be before it adds new TNTs. It will be before that. It will be before that. So here we do world. Push other TNTs at the position. At the position. Let's see now if we explode the TNT, will it blast other TNTs away from it? Will it blast other TNTs away from it? Let's see if it will blast off this TNT. Ah, it it went towards it. So we need to inverse it. It went towards it. Push other TNTs. We need to like this minus this. Yeah, should be like this. Okay, let's test it out. Let's test it out. Now it should push this TNT to that direction. Let's normalize it and increase it by some kind of a size. Here, vector 3 normalize the difference and we scale it by 10. We scale it by 10. Do you want to play Minecraft clone I made? What do you mean? Let's test it again. And let's see what happens. Oh, wait a minute. Yeah, let's test it again. So this one should explode and it should push this one to there. It didn't. Oh, let's try something a bit different. Let's make it be up a bit. Off, not... Come on, man, I'm stupid. Let's make it here and here. Here. Okay. And now let's see if it pushes it. Yeah, it pushed it. It pushed it. It pushed it. It pushes it. Look at it. What about like this? It pushes just one of them, I think. I think it just pushes one of them. No, it shouldn't be just one. It should be... Yeah, let's try again multiple ones. Like this, multiple ones. And let's see what happens. No, let's blast origin. Let's copy blast origin. I think we are probably making some changes here. Let's do vector 3 difference. Let's do this. Subtract vector 3 subtract. Let's do this just to be sure we are not changing some positions. Is it fine? It didn't move it. I'll have to do a breakpoint probably. Maybe. Yeah, and this is the distance. Yeah, let's do a breakpoint. Let's do a breakpoint. Here, if we manage to reach here. And we'll use the debug maybe. Debug configuration. But in debug configuration it will be a bit slower, a lot slower. But I just want to see the... Okay, we just need to bear 5 seconds in this bad version. Just to see... Okay, we got a breakpoint, perfect. So the distance is 0. Distance is 0. Oh, that's why it was like that. Yeah, distance is 0. So blast origin is 28, 116, 2. And here this is 28, 116, 2. Why are they the same actually? Oh, bro, I think this is the original one. That's the original one. It's blasting itself off. And now this is the other one. Difference is -1, 1, -1. And distance is 1.73. Perfect. And here, so we normalize it and multiply by 10, right? So we... Yeah, let's see what the actual value is. Vector 3 normalize difference times 10. Okay, let's remove the times 10. Vector 3 normalize difference. We can do it here. Vector 3 offset equals this. We want to see the value. And here plus offset. Like this. And what else? We want also to ignore the current one when the distance is 0. And distance is not 0. Yeah, if distance is not 0 and it's less than 5. Oh, okay, if it's greater than 0 and less than equal than 5, we do this. Okay, let's test it out. Just follow, thank you, man. Just now I noticed that you're live on Twitch. Well, usually the limit for me is like 3 hours and we're like 3.5 almost. But I really want to finish this. Make a TNT sliding on the ground while being ignited. Bro, TNT doesn't slide. It may move a little bit. It may move a little bit. That's something I can do. Okay, perfect. And what's the offset? Offset is 7 on the Y, so it will go up, and -7 on the Z. And what's up with this update? Doesn't matter. Let's go back in release. So it looks fine, actually. It looks fine. Yeah, it looks to be working. It looks to be working. Let's test it out here. Yeah, let's test it out here in release mode. Looks to be working. Let's see, do they blast off? They blasted off, kinda. Yeah, it blast off. It blast off. Okay, perfect. So about the sliding. About the sliding. Where is Minecraft? About the sliding. About the sliding. Yeah, look at it. It just pushed up. That was the sliding. It just pushed up. Let's commit this. TNT explosion pushes other TNT. Like this. And so what now? You're from Bulgaria? Yes, I am. Let's make it when you ignite it. So when it's created, to move a little bit. But also when other TNT ignited, does it do the same? Does it do the same if like... if it ignites from explode? Yeah, it kinda. Okay. So we can do this. How are we going to do this? Bro, I'm removing you. Because I don't like you. I don't like you, man. I removed you. So let's make it move up a bit. Let's make it move up a bit. When we create it in a random direction, to jump up a bit in a random direction. How are we going to make it work? So many. How are we going to make him? We need a random direction. We'll use the particles. We'll use the particle. We'll use the particle here. We'll use the particle. Yeah, this thing. And the velocity will be that. Yeah, that will be it. So TNT and here, where do we set the velocity? We don't set it. Here we set it. Okay, like this. Perfect. Okay, we are taking a random direction, and here we give it like 2.5 boost in that direction. But we need to dump it, the velocity, because it will continue in that direction for forever. But I have to sleep. See you tomorrow. No problem. Okay, if we right click it. Bro. Bro. This random direction was wrong. Yeah, it needs to be to the up. So the yaw and pitch, which one is for up and down? The pitch probably. So the up and down to be from 0 to 180. 0 to 180 to be the pitch. Yo. No. A bit more up. So like from 15 to like 180 minus 15. Yeah, we tested it on water. It removes water. Yeah, look at it. Now they jump around a bit. And they blast off, man. Yeah, that's cool. And let's make the scale change at the end. Let's make the scale change at the end. So when we have a second, I think snow is supposed to fall. Don't worry about it. Don't worry about it. About the TNT. Let's have it have a scale. Float scale equals 1. Yeah, by default equals 1. And here in the update, we'll check time. What are we going to check actually? We want to see how much time is left until explosion. Float time left till explode equals, let's do float current time equals get time. So time left until explosion. Let's see time till explode minus current time minus time created. Sure. And here we'll determine the scale based on this. So if time left till explode is like under or equal than a second, we set the scale to be equal to how much? 1 plus 1 minus no, by how much? Because this decreases the time left until it explodes. It decreases, and we want the scale to increase as it's about to explode. How is that going to happen? How is that going to happen? We can do a lerp. Like Raymaf. Let's look at Raymaf, the cheat sheet. Let's look at Raymaf, the cheat sheet. Lerp. Yeah, this thing, lerp. Need lerp between, what's the start? The start is 1, the end is 2, and the amount is time left till explode, like this. Perfect. And so this decreases from 1 to 0, it decreases. So let's do it, let's invert it from 0 to 1. Yeah, okay. Lerp, basically, you give it 2 values, and it gives you a result between the 2 values. It gives you a result between the 2 values, depending on like a certain, depending on a third value. Okay, let's see if it increases size at the end. Oh, we're not using it. We're not using it. We're not using the scale. We're not using the scale. Yeah, interpolation. Let's test it out. Now it should increase the scale at the end. Let's change it. Let's change it. Yeah, here. Let's make it be from 0.5. And here 0.5. Let's make the scale smaller. A 100 scale. Oh, no. Here as well, 0.5. 0.5. Do you have oscillating value you can use for the little TNT size up and down? What do you mean? Okay, let's see. if it scales. Let's kill that. Why? Yeah, it's oh, it's scaled down. Yeah. Okay, let's try again. Let's try again. Huh? Does it scale? That's kind of weird. Let's make it be 0.25. 0.25. Okay, let's scale it like 100, as you guys suggested. But the scale needs to happen from the center. That's been a bit of a bummer. The scale needs to happen from the center. That's a bit of a bummer. What? Yeah, looks good. Yeah, let's keep it to be like before, but how to make it scale from the center? Actually, draw a model, and this is the scale. So it's this. When we create the model, we need to create it from the center to be. No, guys, it's fine. It's fine. It's fine. It's not that bad. Like, even if it doesn't scale from the center, it's not that bad. Yeah, it's not that bad. It's fine, guys. It's fine. Let me change one last thing, and we'll probably try 1000 TNT explosion. Here, let's make it be from 30, and here minus 30, or like 45 minus 45. Let's try that, and we'll try to do 1000 TNT. Yeah, it's cool, man. Yeah, this is so cool. I should stay as white. It should stay as white while being scaled. Okay, we can easily do that. So where do we update? Here? Well, we can just do the color alpha to be always 255. To be always actually to be always 63. That's just the color overlay. Yeah, it will stay as white. And I'm happy with this result. I'm happy with this. Now it will stay as white at the end. Yeah, it stays as white. Yeah, that's cool. That's cool. What's your name on GitHub? Why do you need it? I have almost nothing there. Like public. Mostly it's private stuff. So, We can try now. We can try 1000 TNT. Let's see what's the limit of the game. Guys, how many TNTs do you think it's the limit for this game? How many TNTs do you think the game can handle? How many TNT to spawn? How many can it handle? 1000? 10,000? Bro. About 7? Okay, we'll do 1000. 1, 2, 3, 4, 5, 6. Okay, this is 7. This is 7 TNT. This is 7 TNT. See, it handles 7. Okay, let's do 1000. Let's do 1000. But let me commit this. What should be the name? What did we do? TNT scales at end of explosion. It scales from the side, but it's fine. It's fine. It's not that big of a deal. So how are we going to spawn 1000 TNT? How are we going to do that? Here, okay. We'll make. Let's make a function here on update here if bro. Okay, here if is key pressed, and let's say the F6 key. F6. I want it to spawn. Let's get the vector 3. Let's do a position details. We'll take the player position. And from here, we'll start spawning 1000 TNT. So we'll do a for loop int x. If it's less than... how much will be for 1000? What's the square cubed? Like, what was it like? Like, there was a square root, and what's the other thing? For 3? What was it called? Square root of 3. Okay. Of 3 C++. Oh no, square root of 3 1000. Square root of 3 calc. Bro. Root calculator. Okay, perfect. So, okay, this 1000 calculate. So it's like 10. Oh, bro, I'm stupid. Yeah, 10 by 10 by 10 by 10. X plus plus. And here we repeat this. We repeat this. This is the Y. This is the Y. This is the Z. This is the Z. And how are we going to do this? We will do it the same way we did it. Where actually? Block. Here we had it. This thing. This thing. Here, this thing. Okay, we need to uncomment it, move it, and here we want this to be size equals 10. So it's 10 by 10 by 10. 10 by 10 by 10, and here we want like this. Like this. Okay, sure. And here, what do we want? We want to set the type to be TNT. Yeah, that's what we want. When we press F6, this should spawn 1000 TNT, which we're going to explode. Do you think the game will crash? Do you think the game will crash? Let me escape from here. Okay. Do you think the game will crash? Do you think it will crash? Let's update the thumbnail. Okay, I updated the thumbnail. Now let's test it. Okay. Also, most of you believe it will not crash. Okay, let's ignite one TNT here. Let's ignite one and see what happens. Bro, it crashed because of the way I go through the entities. Why? Okay, let's first update them and then delete them. Let's do that then. Let's do that. I think it's possible to make it work. I just need to figure out where the crash is coming from. And let's see if... Oh, bro. Let's see what happens. It's the same thing. Here, the update. What's the issue? Size? Yeah, they are... Entity. But I don't have multiple threads. Like, this is the only problem, the iterator. That's the only problem when we're iterating over this. Let's change the iterator then. Let's change the iterator to be this one. And here, iterator. Like this. Let's do this. The chain reaction adds entities. It creates entities and we're iterating over them. This shouldn't be an issue. It shouldn't be an issue if we are in a single thread. Wait, what happened? Let's make this be a reference. Const reference. Let's make it const reference. And let's try again. What's your problem? Oh, it's an infinite loop. Here I need plus iterator. I need to increase it. I need to increase it, please. Sure, we can do it here as well. So, oh, it's const. So, like, we can do then the opposite. This. Oh, come on, man. Like, I want to iterate. I want to iterate. Iterate vector C++. Let's see. Oh, wait a minute. It's a vector, right? Auto. Oh, yeah. Okay. I get it. Yeah. Yeah, it's fine. But I don't know if it will... I don't know if it will... Yeah, it's fine. It's fine. But I don't know if that will fix it. The weird crash. I don't know if that will fix it. Instantly. Why, man? But it's a vector, bro, it's a vector. It's a vector. We can just do for int I equals 0, I less than data entities size, I plus plus. We can just do this, it's fine. World data entities, I update. Can just do this then. Can just do this. And let's see what's up. Hi, why are you making Minecraft clone? Why are you typing this message? Oh, is it just freezing? I think it's just freezing. It's not a crash, it's just freezing. Bro. But that's a good thumbnail, thank you. That's a good thumbnail. Don't mind if I do. Yo. We could... where is chat? Here. Oh, bro. It was just luck. So that's the explosion we got. Yeah, but now it manages to work. Okay. Let's try something else. Let's... here, push TNT. Let's not do this. Let's not push other TNT. Let's not push them. And do the 1000 TNT. And see what's up. Bro, then it's the raycast. Yeah, it's probably the raycast. I think one thing we could do, not right now because we are way over time. One thing we could do is to have a request for a raycast, for an explosion. And if explosions happen near each other, to combine. So that we don't do too many raycasts. Probably. Bro. That's kind of disappointing. Yo. That's kind of disappointing. That's kind of... but it's fine. It's fine. Can spawn 1k TNT. Cannot explode them without luck. That face. Add culling. Okay, let's do a summary. That will be the end for today. But let's do a summary what happened in this stream. So, we added this TNT. And I'll show you how it looks like in the original. Here is it in the original. We don't have particles. But in the original, you can right click it. It flashes for a bit and then it explodes. And in my game, like an improvement would be if we make the crater smaller. In my game, the crater is bigger. But in my game, where is my game? Here, in my game, we added it. We can right click it, it flashes and it bounced a little bit if you noticed, and it increases in size a little bit and it makes too big of a crater. It's too big. If we shorten it, we'll be able to do 1000 explosions probably. And it becomes an entity as well. Look at how it falls down, and it can push other TNT as well. It pushes other TNT. It pushes other TNT. And it ignites other TNT as well. This one will explode. It ignites it, and now this explodes. Like, bro, for like 4 hours, that's enough, man, for 4 hours. And we managed to spawn like 1000 TNT, but sadly, it just lags when we do 1000 TNT. It just lags. Yeah. All of them exploded this time. So my idea is to make the explosion smaller. That's my idea. Here, let's make the explosion smaller. So maybe to decrease the race or to decrease the size, maybe, question mark? I'll see about it. Optimizations will be for other time. It's fine. It's fine. But we have TNT, man. We have TNT. I'm very proud, man. I am very proud with the result. Yeah, and this was very good, man. Like, that's very good, man. Yeah, that's my bro. That's so cool, man. Bro, that's so cool. Yo, thanks for the follow. Yeah. Yeah. And so that's it, guys. Thank you for being here. Thank you for watching. Whoa, you aren't finished? No, bro, what do you mean particles? Like, there's a limit to this. Yeah, bye, guys. Thank you for watching.